In this video, I am going to share the most crucial ideas with you. You could rather make a mix and match with your thoughts and make simple steps for getting a brilliant solution. So please squeeze some time out and try and adapt and learn from this video so that definitely your solving skills will immensely improve. Now coming back to today's topic is rules of inference. So this is from mathematical logics and this is related to MFCS, DMGT and DMS. So these are the 5 questions which are very important. So don't miss this video until the end so that you will be benefited. At least one question will be seen in the question paper. So these are all the questions related to rules of inferences without using the truth tables, because I'm going to use the rules of inferences with the important formulas. See here how to solve these 5 questions using the rules of inferences. So they are two rules here, the rules of inference. So according to the rules of inference, the following are the two important rules of inferences. First one is rule P. So rule P means a premise may be introduced. So if we introduce any premise, so we have to apply rule P at any point in the derivation. So at any point in the derivation, if you introduce any premise, so this is rule P. So how about this rule T? A formula S may be introduced in the derivation. So introduction of a formula, if you introduce any formula in the introduction of the derivation, it is rule T. So we have to apply rule P as well as rule T. Rule P is nothing but introducing a premise and applying a formula is rule T. So rule P is nothing but introducing a premise. So what is rule T? Applying a formula while derivation. So these are the two rules which you have to use in the rules of inferences. So here these are the important formulae which are very useful for our solutions. See here, as you know that P implies Q. So as it is the most important thing, P implies Q is nothing but negation P or Q. So here negation P or Q. And next one, P comma P implies Q. See here, so this is P and this is nothing but P implies Q is nothing but negation P or Q. Clear? So this is a negative statement, this is a positive statement. So what remains here? Q remains. So Q is the answer. P implies Q is nothing but Q. These both get cancelled. See here, as this is a negative and this is a positive statement, and what remains here? Q remains. And this is also very easy to remember. If P implies Q and Q implies P, see here, these two are equal, similar. So we can join these two, which is equal to P implies R. So this is also very easy to remember. And next one, negation P implies Q. So this is negation Q. So what is P implies Q? P implies Q is nothing but negation P or Q. See here, this is a negative statement, this is a positive statement. What remains here? Negation P. So this is also so easy to remember. And this one is P implies Q is equivalent to, see here, if you apply negative statement, negation Q implies negation P. So this is also so easy. And next one, negation P implies Q. For P implies Q, what is the formula here? Negation P or Q. So in place of P, we have negation P or this is Q. Negative into negative, which will be positive, which is equal to P or Q. So this is how you have to remember. Please take some time to learn this so that the solution will be very easy. P implies Q is nothing but negation P or Q. P comma P implies Q, which is equivalent to Q. And next one, P implies Q, Q implies R, implies P implies R is the answer. Next one, negation Q, comma P implies Q is nothing but negation P. P implies Q. If you apply negative statements for both, then this will be negation Q implies negation P. Negation P implies Q is nothing but P or Q. So I am going to use all these formulas. See, take some time and practice. And the first question here is, demonstrate R is a valid inference from P implies Q, Q implies R and P. The first question here is, the solution for the first question is, we have to demonstrate that R is a valid inference for the premises P implies Q, next Q implies R and P. So these are the premises. So any one we can take of our choice. See, first thing here is what we have to do is I am going to take the premise. The first premise which I am going to take is P implies Q. The first thing which I am going to take is P implies Q. For that, the first thing is the premise number is 1. So the serial number is 1. What is the premise which I am going to take? That is P implies Q. So if I introduce any premise, what is the rule which I have to apply? So this is rule P, and there is no formula for this. And the next thing here is the next premise which I am going to take is P. So this is the second premise which I am going to introduce. So this is premise number 2. And this is serial number 2 and this is P. So I am introducing the premise, so it is rule P. Clear? And the next one I am going to apply the formula on both the premises. Therefore 1 comma 2, among 1 and 2 I am going to apply the premises, and this is the third step which I am going to take. And which formula we have to introduce? If I introduce any formula, it is rule T. So between 1 and 2, I am applying a formula. Which formula it is? So P comma P implies Q. As P implies Q is nothing but negation P or Q. This negation P and P got cancelled, and what remains here? Q remains. And see here, my answer is Q here. Clear? And the next thing here is, next introduction of the premise is third one. So this is the third premise which I am going to introduce. So here, so this is my fourth step, and this is the fourth step which I am going to take, and this is nothing but Q implies R. So I have introduced this premise, therefore this is rule P, and there is no formula. So among these two, 3 and 4, I have to introduce a formula. Therefore between 1, 2 and 4, between 1, 2 and 4, this is the fifth step. See here, Q implies R. So I am going to apply rule T. So rule T among 3 and 4, among 3 and 4 steps. So what is the formula which I am going to apply? Is nothing but P implies Q is nothing but. So this is P, negation P or Q. Negation P and P got cancelled, and my answer will be Q. And here also the same case. This is Q, negation Q or R. Negation Q and Q got cancelled, and my final answer is R. So this is what it is asked to show, that therefore we say that R is a valid inference for the premises P implies Q, Q implies R, and P. And this is how we have to solve. So R is our final answer. This is how we have to get using the formulas and without using the truth table. First I have taken premise 1 as P implies Q. As I have introduced the premise, it is rule P. And next thing here is, next premise is P, and this is P. This is also rule P because I have introduced one premise. So I have applied the formula on 1 and 2. So on 1 and 2 I have applied. This is the third step, and the answer here is Q because I have introduced a formula. This is rule T among 1 and 2. So which formula I have introduced? P implies Q is nothing but Q. And the next premise which I have introduced is Q implies R. And this is the fourth step, and this is fourth step. And see here, this is rule P. If I introduce any premise, it is rule P. And the next one among 1, 2 and 4. So among these two, I have applied a formula. This is rule T among 3 and 4. And here the formula is R. So which formula I have applied? P comma P implies Q is nothing but Q. Hope you all guys understand, because this is the easiest process. These are the steps which you have to take, and definitely you can solve any question of this type. And the next thing here is, the second question here is, show that R or S follows logically. So these are the formulae. So these are the four premises which we have to take. So we can take any one of the premises of our choice. So first I am going to introduce the rule 1. So according to my wish, I am taking the premise. So I'm introducing this as my first premise. See here, the first premise is number one. So this is serial number one. The premise which I'm going to take is negation H implies A and negation B. So I'm introducing this premise. This is nothing but rule P. So there is no formula for this. And the next premise which I am going to use is, see here, for this which I am going to apply, as I am going to take the first premise as this one, that is C or D. C or D implies, see here, this is C or D implies this is negation H. So this is rule number P. See here, first I have taken this as premise 1 and this is rule P. And the next thing here is, this is the second step. So the next premise which I am going to take is this one. So this will be negation H. So this is negation H implies A and negation B. So this is also rule P. So as you can see, I am going to apply 1 and 2. So this is 1 and this is 2 and this is the third step. So I am going to apply the formulae on 1 and 2. If you see, this is negation H and this is negation H. So which formula I am going to apply? That is P implies Q and Q implies R. See here, there is Q common in between these two. Therefore, negation H is common in between these two. P implies Q and Q implies R, which implies P implies R. Clear? So, if I introduce any formula, this is rule T among 1 and 2. Among 1 and 2, I have applied a rule and this will become P implies R. So, this will be C or D implies A and negation B. See here, A and negation B. And the next thing here is, now I am going to introduce the another premise. So this is the another premise which I am going to take, and this is step number 4. So this is step number 4. This is the fourth serial order. This is A and negation B, which implies R or S. Clear? So if I introduce any premise, so we have to take a rule P. So here it is also very clear. P implies Q and P implies Q and Q implies R. So if I apply any formula on this, so if I apply the formula on 1, 2 and 4. So this is 1, 2 and 4. If I apply any formula, this will be our fifth step. And see here, if you see, these two are common. So I am going to apply a rule, a formula, that is P implies Q and Q implies R, which implies P implies R. And now this is P implies Q and Q implies R. Now I am writing, that is C or D implies R or S. So I have applied a formula. So this will be rule T for 3 and 4. So among 3 and 4 I have applied rule T. And the next thing which I have to do is I have to introduce another one, another premise. So this is the fourth premise which I am going to introduce. See here. So this is my sixth step. So this is my sixth step and this is also a sixth step. I am going to introduce C or D. So if I introduce any premise, this is rule P. And next, among these two, I have to apply the formula. See here, among, see here 1, 2, 4 and 6. So this is 1, 2, 4 and 6. So this is my seventh step, and see what happens here. So I am going to apply a formula. This will be rule T among 5 and 6. So what is the rule which I am going to apply? So as you know that P comma P implies Q, which is equal to Q. So P implies P or Q. So this is P and this is P implies Q. This will be negation of C or D or R or S, and this is C or D. Negation of C or D and C or D got cancelled, and what remains? R or S. So this is R or S. So this is what it is asked to show that. See here. So R or S follows logically all the four premises, all the four premises. See, first of all, in our introduction I have taken C or D implies negation H. So this is, if I introduce any premise, so this is rule P. And after that one, the second premise which I have taken is negation H implies A and negation P. So this is also rule P. So as there is negation H common, so I am joining these two, that is P implies R. So this is rule T I have applied. So this is the formula. And the next one, introduction of my next premise, the third premise which I have introduced here. So here in this case also, so in this case if you see A and negation B, so both are common, so I have to join this P implies R. So this is the formula which I have applied. So if I apply any formula, this is rule number T. And next one here is C or D. This is the fourth premise which I have introduced. If I introduce any premise, this is rule number P. And next one here, on applying the formula on these 5 and 6. So this is 5 and this is 6, and if I apply any formula, this is rule number T, that is P implies P or Q will be Q. So this, there is P for 2 times and this is Q, and R or S is the final answer. This is how we have to solve. So this is also so simple. If you introduce any premise, please take rule P, and if you apply any formula, please take rule T, and the formula also have mentioned. And the next one, third question here is also very easy. See here, show that S or R, see S or R is tautologically implied by, this one is P or Q, P implies Q and Q implies S. See here, there are 3 premises here. So first thing which I am going to take is, the first thing here is, this is the first one. So this is the first step. This one is the first thing which I am going to take is P or, this is P or Q. If I introduce any premise, so this will be rule P and there is no formula. And the next one is, I am changing this one for my convenience as P or Q can be written as negation P implies Q. So I have applied a formula on this. So this is rule T on the first one. So what is the rule which I have applied? So this is nothing but P implies Q is nothing but negation P or Q. So if I apply, this is negation of negation P or Q, so which is equal to P or Q. So if I apply implication formula on this, so we'll be getting P or Q. And the next thing here is, so this is our second step. So this is 1 and this is 2. In my third step, which thing I'm going to introduce is, this is the premise which I'm going to introduce. So this is nothing but third step, and this is Q implies S. So this is again rule P. I am introducing a premise. So this will be Q implies S. And next one here is, in between these two I am going to apply a formula. See here, this will be among 1 and 3. So this is my fourth step. As you see that Q is common in between these two. So Q is common in between these two, and therefore I am applying rule T. So I am applying a rule T among 2 and 3. So which formula I am going to apply here? So as you know that it is very familiar. P implies Q and Q implies R, which implies P implies R. So these two are equal. So P implies R. So if these two are equal, so which one we have to join? That is negation P implies S. This is negation P implies S. And in my fifth step, see here, so I am adjusting this one as, this can be written as negation S implies P. I have applied rule T. So I have applied a formula on 4. I have applied a formula. So that formula is also very easy, as P implies Q is equivalent to negation Q implies negation P. So if I introduce negation on both sides, this will be negation Q will come front and negation P will be in that side. So here if I apply negation on these two, negation X, negation S implies negation of negation P, which is equal to P. And next one I am going to introduce this third premise. So next one here is third premise, and this is the sixth step, and this is 6, and this one I am going to introduce as P implies R. So I am introducing a premise as, this is rule number P. So if you observe properly, so this is P implies Q and Q implies R. So P is common in between. Now I am adjusting these two. So now I am going to apply a formula on 1 comma 3 comma 6. Clear? And this is my seventh step. See, this is rule number T. I'm applying a formula on 5 as well as a 6. So what is the formula which I'm going to apply? So this is also so simple, that is P implies Q and Q implies R, which implies, so Q is common, so I am rejoining this one, that is P implies R. Now P is common in between, now I am joining this one as negation S implies R. So negation S implies R. So among this one, I'm again going to apply a formula, that is 1, 3 and 6, and this is my eighth step and implication formula. So this is rule T. I'm going to apply a formula on 7. So which formula I'm going to apply? That is P implies Q is nothing but negation P or Q. So this is negation of negation S, so which is equal to S or R. So this is what it is asked to show that. And finally we got S or R, and this is S or R. We have to show that S or R is tautologically implied by these three premises. First of all, I have introduced this premise 1 as a P or Q. As I have introduced a premise, this is rule P. So I have written in form of an implication formula. The formula is applied. So this is rule T, that is P implies Q can be written as negation P or Q. See here, so if you take negation of negation P or Q, we'll be getting P or Q. And the next thing is the premise Q or S. Q implies S is taken. This is rule P. And see, as Q is common in between these two, this can be written as negation P implies S. Rule T applied on 2 and 3. And this is the formula. And the next one here is I have applied negation on both sides. So this will be negation S and negation of negation P, which is equal to P. After introducing this P or R as premise 3. So this is rule number P. And see, if you observe this one, P is common. Therefore, negation S or R. And using this implication formula, this is negation of negation S or R, and this is our final answer. Hope you all guys understand how to take the steps. While introducing, we have to apply rule P, and while applying a formula, we have to take rule T, and we have to mention that formula as well. And next one, show that R and P or Q is valid conclusion from the premises. So these are the premises, that is P or Q, Q implies R, P implies M, and negation M. So these are the premises or which we have to take. So this is the premise number, this is the serial number, premise and rule and formula. And see here, we have to show this one is the final answer. It is a valid conclusion from these total premises. The first thing here I am going to do is, the first thing is, we have to introduce a P premise. So this is 1 and this is 1. So first I am going to take P implies M. So I am taking P implies M. So if I introduce any premise, so this will be rule number P. And the next one here, the second premise which I am going to take here is, so this one I am going to take. So this will be the second one, that is negation M. So this one is negation M. So I have introduced a premise. This is rule number P. And the next thing here is, so among 1 and 2. Among 1 and 2. So this is the third step which I am going to apply. So here I am going to apply the formula, that is rule T for 1 as well as 2. So this will be, the formula will be negation Q implies P implies Q, which is equal to, see here, this is negation Q, this is negation P or Q. So Q and negation Q got cancelled. So this will be negation P. Negation P will be the answer. Here also the same case. Negation P or M. M and negation M will got cancelled. And this will be negation P. And see here, and the next thing here is I am going to introduce this one as premise, and this one is the fourth step. So this is the fourth step, and this is 4 and premise 4, and this is P or Q. If I introduced any premise, so this will be again rule P. And next one, So this conjunction, so this disjunction to implication formula I'm going to apply. So this will be the fifth step. So this will be negation P implies Q. So I have applied a rule T on 4. So what is rule T? So implication formula, that is P implies Q, is nothing but negation P or Q. So negation P or Q. So I have applied the implication formula. And the next one, my fifth step. See here, and among these two, so which one? So this is negation P and this is negation P or Q. So I am going to introduce a formula here, among 1, 2 and 4. So this is among 1, 2 and 4. I have taken a sixth step. So this will be, if I apply any formula here, this will be negation of negation P or Q. So this is negation P and this is negation P implies Q. And now this is negation of negation P or Q. And this one will be Q. And this is a rule T. So I have applied formula on step 3 and step 5. See here, among these two, step 3 and step 5, that is P implies Q will be the answer. See here, P implies Q. So Q will be the answer. And the next one here is, the final premise here is Q implies R. So now I am going to introduce as the seventh point. So this is point number 7. So now I am going to use Q implies R. So if I introduce any premise, this is rule number P. So this is P comma P implies Q. Again the same formula. What remains? R remains. So here R remains among 1, 2, 1 to 4 comma 7, among 1 to 4 comma 7. This is the eighth point, as I have taken a formula. So this is the formula here, among 7 and 8, sorry, 6 and 7, among 6 and 7, among 6 and 7, which formula I have taken? That is P comma P implies Q, which is equal to Q. So this formula I have applied on these two, P comma P implies Q, which is equal to R. So what is the answer I have needed? R and P or Q. So where is P or Q? So this is P or Q. So I have seen P or Q here, and this is R. So if I rejoin here, so if I rejoin this step, that is 4, 1, 2, see here. So this will be 1, 2, 4 and 7. See here, this is 4. This is 1, 2, 3, 4 and 7. So I have to make a conjunction with this, that is R and P or Q. So this is the formula which I am going to apply, that is rule T on the fourth statement and the eighth statement. This is eighth statement. So as the formula is very clear, as P comma Q is nothing but this is P and Q. See, this is the ninth step. So this value is the ninth step, and finally we got R and P or Q. So this is what it is asked to show, that the first thing is we have to use the 4 premises one after the other or as per your wish. The first one I have taken is P implies M. So P implies M. If I introduce any premise, we have to take it as a rule number P. And the next premise which I have taken is negation M. So among these two, so I have applied a formula. See, rule number T on 1 and 2. So which formula I have applied? Negation Q, comma, P implies Q is nothing but negation P. So I have taken negation P. And the next thing is I have introduced this formula, that is premise, that is P or Q. This is rule number P. So if you observe this one, so the formula here is negation P or Q. I have modified this one. So this is a disjunction, and I have taken an implication formula using this formula. And the next one I have introduced this one, Q. So this will be the rule number 7. So according to the rule T, that is among 3 and 5. So among 3 and 5. So this is P implies Q, which is equal to Q is the answer. And the next one I have introduced Q implies R here. So this is rule number P. I have applied P comma P implies Q formula as Q. So what remains here? R. So we need the answer as this one, R, P or Q. So here there is P or Q and this is R. So I have applied the formula on fourth statement, 1 2 3 4 7. So this is 1 2 3 4 7 statement. This is the ninth step. This is R and P or Q. So this is rule number T. Rule number T on fourth statement and eighth statement. So which is nothing but P comma Q implies P and Q. So this is the final answer. And the next thing, the last thing is, now we have to show that negation Q. P implies Q implies negation P. The first thing here is, first we have to introduce a premise. So this is the first step. The first step which I am taking is P implies Q. So this is P implies Q. So if I introduce any premise, this is rule number P. And the next thing here is, so we have to modify this one. So after modifying this one, so again on premise 1, step 2, if I take negation on both sides, this will be negation Q implies negation P. I have applied rule T, formula T on 1. So which formula I have applied? So which is nothing but P implies Q, which is double implies as negation Q implies negation P. And the next thing here is, now I am going to introduce this second premise. So second premise. So here the third step, and this one is the third step. So I'm going to introduce negation Q. If I introduce any premise, what we have to do? So this is rule number P. So among these two, see here, look here. So this is P and P comma Q, which is equal to negation P. So I am going to apply I've taken 1 and 3 premises. This is my fourth step. See here, negation P and negation P. So this will be P or negation P. So this will be negation P. I have applied the formula on T among the statements 2 and 3. So which statement I've taken? P comma. So this one, P comma P implies Q, which is equal to Q. So if you observe properly, so this will be negation of negation Q or P or negation P. And this is negation P. So this is Q and negation P got cancelled. And what remains here? Negation P remained. So if you introduce any premise, we have to write rule P. And if you apply any formula on it, we have to write rule T. And so these are the steps which you have to take in. So negation P is the final answer from these two premises. And these are all the important questions. Please go through this video for one more time if you don't understand, but don't miss this, because among these 5, at least one will be seen in your question paper and you will be benefited with good score. And thank you so much for watching and staying till the end. If you really like this video, you know what to do. Please practice and please pass it on to your friends. And please look at my next video too. That is also very, very important. And thank you so much for watching and staying till the end.